video, we will learn how to write complete and net ionic equations. So there are different formats of writing chemical equations. So far, we've only seen molecular equations. In molecular equations, that's what you've seen so far, everything is written as compounds. I realize that these are ionic compounds, not molecular compounds in this example, but it's still called molecular equations. No matter what kind of compound it is. Everything is written as compounds. So everything is bonded together. And so that's what we've seen so far. If we can use this as a practice to use our double displacement reaction pattern type to predict the products. According to our double displacement reaction pattern, we have to break this apart into ions. I'm going to try to erase that line. There we go. We have to break this apart into ions. And this is our nitrate. And that's our magnesium 2+. Our magnesium will bond to our hydroxide. And our potassium will bond to our nitrate. And so potassium and nitrate together, potassium is 1+, nitrate is 1-. I'm going to leave myself a blank for balancing. And then I need to leave myself a blank for balancing the other compound as well. Magnesium is a 2+ and hydroxide is a 1-. And so to make a neutral ionic compound, I'm going to need 2 hydroxides. So I have to put hydroxide in parentheses. Now I can apply my solubility rules, and I find that potassium nitrate is aqueous, and magnesium hydroxide is insoluble, and so it is solid. Now that I have my products, I can balance the equation. On the reactant side, I see 2 nitrates, and so I'm going to put a 2 coefficient here to give me 2 nitrates on the product side. That 2 coefficient also gives me 2 potassiums, and so I'm going to need to put a 2 here in order to balance my equation. I have 2 potassiums, 2 hydroxides on the product side, 1 magnesium on both sides, and 2 nitrates on both sides. But we have to remember that strong electrolytes completely ionize in solution. So strong electrolytes completely ionize. And so that means that instead of NaCl aqueous, what you really have is sodium plus ions that are aqueous, and you have Cl- ions that are aqueous. And so writing it like NaCl aqueous doesn't really represent what you have in solution. And so we have other formats of chemical equations that help describe what's actually in solution and what's not. So in a complete ionic equation, also known as a total ionic equation, our aqueous strong electrolytes are written as ions. And so we're looking for soluble ionic salts, strong bases, and strong acids. Those are our strong electrolytes. Everything else is written exactly the same as in the molecular equation. I'm going to switch colors so that we can rewrite our equation above in a complete or total ionic equation format. So first of all, we have to identify in our molecular equation which ones are aqueous strong electrolytes and which ones are not. And so the first thing you should do is look at the state symbols. If you see an aqueous symbol for now, wait, and we'll figure that one out later. This compound over here is a solid, And so I'm going to copy it down straight as it is because it's not aqueous. It has to be aqueous for us to write it as ions. Next, I'm going to look and see if any of these are ionic compounds, strong acids, or strong bases. So potassium hydroxide is an ionic compound, or you could think of it as a strong base. Either way, it's going to need to be written as ions. Now we have to remember that this 2 here applies to both the potassium and the hydroxide, so it distributes out. The aqueous also belongs to both, and so that distributes out. So we have 2 potassium plus ions that are aqueous, and we have 2 hydroxide ions that are aqueous. In this next compound, I have magnesium ions and I have nitrate ions. This is an ionic salt, ionic compound, and so I have to write it as ions as well. And so I identified earlier that that was made up of magnesium 2+ cations. That aqueous does apply to both. I also have nitrate ions, and I have 2 nitrate ions. And so that 2 needs to come out in front because the nitrate ions do not stay bonded together. They are 2 separate nitrate ions. And so the 2 comes out in front. Each nitrate does have 3 oxygens, and so that 3 does need to stay there because each nitrate has 3 oxygens. If we moved the 3 out in front, then it would look like we had 3 polyatomic ions that just had 1 nitrogen and 1 oxygen, and that's not what we have. So now we'll move on and do this compound. This is also aqueous, and it's an ionic compound. So all of these are ionic. We know they're ionic because there's a metal with a polyatomic ion in all 3 of those compounds. And so that 2 distributes out, and the aqueous also distributes. So we have 2 potassium ions that are aqueous, and we have 2 nitrate anions that are aqueous. All right, so that should be our complete ionic equation. We can double check this because this one should also be balanced. And so I can double check, yep, I still have 2 potassium ions. I still have 2 hydroxide ions on both sides, 1 magnesium, and 2 nitrates on both sides of the equation. But you might have noticed that some of these things don't actually change from side to side. So on both sides of the equation, I have 2 potassium ions, and we have 2 nitrate anions. And so these don't change. And so these are our spectator ions. Our spectator ions do not change in a chemical reaction. They just watch what happens, like spectators. So all we have to do to write our net ionic equation is cross these out. Cross out everything that doesn't change. So my nitrate on this side cancels my nitrate on that side. My potassium here canceled with that potassium. And so now in my net ionic equation, I write what actually changed. And so my magnesium 2+ cations that are aqueous, and my 2 aqueous hydroxide anions turned into magnesium oxide solid. And so all three of these different chemical equation formats should be balanced. If they are not balanced, then you have messed up somewhere and you need to go double check your work. Okay, here's a practice problem for you. Go ahead and pause the video and try to work it out on your own. Okay, let's go over this. So I need to first identify what needs to be ionized in my complete ionic equation and what shouldn't. And so this is aqueous, aqueous, aqueous. So now these might need to be ionized. My barium sulfate is solid. And so I'm just going to copy it down. And I know that that's going to need to appear in my net ionic equation too. Because I don't have solid barium sulfate on the reactant side anywhere. Now, these are all aqueous, and so I'll identify whether they're ionic compounds or not. So here we have my potassium sulfate is ionic. Barium nitrate is also ionic. And potassium nitrate is also ionic. So all three of these compounds will need to be ionized. Next up, I'll identify the ions that make up each compound before I get carried away. And so that's potassium. Each potassium ion will be a +1. Each sulfate will be a 2-. Barium likes to be 2+. Nitrate is a 1- anion. Nitrate here is also 1- ion. Potassium is a plus ion. Barium is a 2+. Sulfate is a 2-. And so now I can write out my equation. I just have to remember subscripts and coefficients distribute out in front. So if you see a subscript on the outside of parentheses, that would be a subscript that moves out in front. Don't move the one that's inside the parentheses. So we have 2 potassium plus ions. And remember the aqueous applies. It distributes out as well. And my sulfate ion. And that's also aqueous. Not too narrow yet. And so I have barium 2+ ions that are aqueous and 2 nitrate anions that are aqueous. Oh, I hope I have enough room. And then that's going to be 2 potassium ions that are aqueous and 2 nitrate ions that are aqueous. So that's our complete ionic equation. I'm trying to change my pen colors. Oh well, it's not letting me change my pen colors. So for my net ionic equation, I'm going to cancel out things that stay the same on both sides. So I see 2 potassium ions on both sides, and I see 2 nitrate ions on both sides. So those are going to cancel out. I also can look at my barium sulfate and think about what ions make up barium sulfate, because those are the ones that are going to stay around. So I'm going to have barium 2+ aqueous plus sulfate 2- aqueous, and those are going to make up my barium sulfate solid. And so all of these are balanced, and so we're done with that one. And so we'll do our last problem down here. We have sodium plus ions. We have carbonate anions. This is a strong acid. It's on your strong acid list, and so that one's going to need to be ionized as well. And that's made up of H plus ions and Cl minus anions. Sodium plus, chlorine minus. This is a gas. That's a liquid. And so just like our solids above, those are not going to be ionized. So solid, liquid, gas do not ionize. So I can go ahead and copy those down before I forget and get carried away ionizing things. Not a 3, that was supposed to be a 2. Okay, and so I'll just start from the beginning. That 2 is going to come out in front, and that 2 is going to distribute. Aqueous is distribute, that's 2 going to distribute. And so I'm going to have 2 sodium ions, and those are going to be aqueous. I'm going to have 1 carbonate anion. I'm going to have 2 H plus ions, and I'm going to have 2 Cl minus ions. On the product side, I'm going to have 2 sodium ions, and I'm going to have 2 Cl minus anions. Now for my net ionic equation. I have to look on both sides, and I see my chlorine on both sides and my sodium on both sides. And so those are going to cancel. And so in my net ionic equation, I am left with carbonate, and I am left with H plus ions, and I am left, nope, that's all I'm left with on the product side, or on the reactant side. And so then on my product side, I have 2 carbon dioxide gas and H2O liquid. Remember that liquid is, or water is not aqueous. Water is a liquid. So we can double check and balance 2 hydrogens, 1 carbon, 3 oxygens. And so I'm balanced. And then if you go through the PowerPoint presentation, it's all written there.